Elementary Algebra, Assessment 4 Review, questions 18 through 22. In question number 18, the instructions read, factor the binomial that is a difference of squares if primes so state. So let's have a review here. On 18 we have an 81 y to the fourth power minus 64. The factoring of a difference of squares is going to be, if we have the a position squared minus the b position squared, it's going to equal the conjugates that are made out of the bases a and b. So I'm looking here. I can square 81, it becomes a 9 squared. I can also square the y to the fourth power, y to the second overall raised to the second power. If you remember the rule, when I look at this, the 2 comes back in. 2 times 2 is 4, so it's the original problem. And then I have a minus 8 squared. So I come down here, and I'm going to use that rule and plug these bases in. So I'm going to have an a plus b, so I have the 9 and the y squared plus the 8. And then I have the 9 and the y squared minus the 8. Now because I have the y squared, I would look to see if I can, on the minus one, if I can actually factor it one more time. The 9 will square, it'll be a 3 to the second power, but the 8 doesn't square. So I'm done with this problem. I can't factor this second binomial a second time. So moving on to number 19. Here I have an x to the third power minus a 1000. Well, when I look at it, that x is already cubed, and we do have a difference of cubes. So I look to see, can I cube the second one as well? And I can. That's actually going to be 10 to the third power. So the difference of cubes rule says that if I can cube the a position and the b position, then I can put it into the form a minus b times a squared plus a times b plus b squared. So I'm going to plug those values in. So in the a position I have an x, so I have an x minus what's in my b position, which is a 10. And then again the a position squared plus the a position times the b position, or x times 10, plus the b position, which is a 10, squared. Let's come back and just clean it up. So I have my x minus 10, x squared, plus I'm going to change the position of the 10 and the x, putting the constant before the variable, and then the 10 times 10 to make the 100. Question number 20 says factor completely if prime so state. So I look at this one and I see that I have 4 terms. First I look to see if I have a greatest common factor. I don't have a greatest common factor between the 4 terms. They don't have anything in common. So I rewrite it and I group them. So I put parentheses around them. But before I did, I want you to notice that in the middle there's a minus sign here. That minus sign, I'm going to turn it to a plus, and I put the negative on the 25x. If I didn't do that, if I put the parentheses and I left that minus sign out there, it would show that this negative is supposed to distribute to both terms, when it's not. It actually only belongs to the 25x. So I need to make sure before I put the parentheses in that I put my plus sign and I put my negative over to that 25x. This is only when we have a minus sign in the middle of the 4 terms. That being said, we put in a parentheses and we look for the greatest common factor from each pair. So in the first one, it's x squared. So the x squared pulls out and I'm left with x minus 1. On the second one, because there is a negative on the first position, whatever I pull out is going to have a negative pulled out with it. So they have a 25 in common, so I'm going to pull out a negative 25 out of each. So negative 25 comes outside. That leaves an x minus 1. So the x minus 1 is what they have in common. So we come in and we factor those out, so x minus 1. And then I'm left with x squared plus a negative 25. Now this problem normally would be done here, but what I see is this: I have an x squared here, and I have a 25 here, and this is a difference, and 25 can be squared. It can be 5 to the second power. So this means that I can continue to factor the second one using the difference of squares. In the difference of squares, if I can square them, then I can take those bases and write them into conjugates. So I still have the x minus 1 here. But I'm seeing that the x squared minus 25 is x squared minus 5 to the second power. So I am going to rewrite this into its conjugates, x plus 5, x minus 5. Now I factor the problem completely. Number 21, when I look at this one, before I start to factor it, I see that the 2x, the 20, and the 50, they're all even numbers, so I could pull a 2 out. So I'm going to factor out a 2, so I divide a 2 out, leaving me with an x squared minus 10x plus 25. Now when I look at this one, that x is already squared, and I can see that 5 can square. It can be 5 to the second power. So I'm looking here, what I want to do is check, this is just like the previous one, where we had a trinomial, where we had the a position squared and the b position squared. If those positions times 2 equal the original, then I can skip to where I have the a minus the b raised to the second power. And I see that 2 times x times 5, it does indeed equal 10x. So I can plug those values in. So I plug down here an x minus a 5 overall raised to the second power. Now, if I hadn't realized, okay, that I had this shortcut here, then I could have just pulled what was in the C position and pulled what was out here in the C position, pulled over here what was in the B position, and ran my factors until I found a pair of factors that multiplied to my C position and summed to my B position. I would have, in the end, come out to the same thing. I would have had an x minus 5 times an x minus 5. On problem number 22, it reads, solve the problem. 22 says Jim drove 252 miles in 6 hours. If he can keep the same pace, how long will it take him to drive 882 miles? So we're going to set up a proportion problem. In the first one, I'm going to look at what we have complete here. We have how far Jim drove and in how many hours. So I'll set that up in a fraction. I have 252 miles to 6 hours. For the other side then, I'm going to plug in the information I have available in the same position. So in the top I have my miles, in the bottom I have the hours. Well, reading back here, all I have from the second half of this word problem is the number of miles, which is 882. What I don't know is how many hours it takes him. So I put it in there and I put it with the variable x. Now for the moment, I'm going to eliminate my units. I'm not going to look back at them, right, until I come to the final answer. I'm just going to look at the values. So I have a 252 times an x for this side. I have an 882 times a 6 for the left side. So then I have 6 times 882 gives me 5,292 equals 252x. Lastly, I'm going to divide that 252 out on both sides so it clears it off the right side, and I find that I have 21x. This is when I want to look back at my proportion. X, the units are hours, so I have 21 hours for my final answer.